Hello, I'm making this video and it's going to cover finding an equation, a quadratic equation specifically given the point and the vertex. So you're given a point on a quadratic function and you're given the vertex, and you can give any type of quadratic equation that goes with it. So let's get into it. Okay, and again, the goal is to use the vertex coordinate and a point to find the equation. And as a reminder, our formula for a quadratic in vertex form is f of x is equal to a times the quantity x minus h squared plus k. And since we're given the vertex, and you know h and k are the vertex coordinates, I think that this is going to be the easiest thing to put into. So let's get started. Okay, and another reminder, all equations have an input and an output, and x is going to be your input and y is going to be your output. And what this is basically saying that, if you have a number x and you put it into the equation, then you're going to get an output y. And remember, equations and functions are kind of the same thing. So a function is the same as an equation. And if you have any type of function like x squared, this is like a machine. You put in 2 into x squared, then 2 is your x, and it'll spit out a number. 2 squared is 4. And so when you write your equation at the end, you still need an x and a y, or an f of x and a x. So just remember that. Okay, let's start. We're given a point at 4 and 2 and a vertex at 3, 6. So our point is at 4, 2, which is going to be kind of maybe here, and our vertex is at 3 and 6, so maybe somewhere around here. And so if the vertex is above the point, then I think we should conclude we're probably going to go down. So we should find a negative number. But basically the way you're going to set up this is that a point has an x and a y, and the vertex is just h and k by definition. And so you're going to plug each of these into this equation. So I'm going to start f of x is equal to a times quantity x minus h squared plus k. And let me get rid of this up here for a minute. Okay, now I'm going to rewrite this, plugging in everything I know, and it's going to be pretty obvious that we just don't know one thing. So f of x is another name for y. So I'm going to bring this 2 down here. I'm going to say 2 is equal to. So this 2 is our y. And then a, I don't know a. And then this is times x. And x is just, well, this is x right here. So we're going to put in 4. And then our vertex is 3. So minus 3, that's h. This is h, which goes there. And then that's squared plus, and then k is here, 6. And so I have 2 is equal to a times quantity 4 minus 3 squared plus 6. Okay? So basically I just plugged in everything. And now if I solve for a, so solve for a, if I can solve for a, then I can rewrite this equation. So let's tackle this first. We're going to do 4 minus 3 on the inside is 1. And then 1 squared is still 1. So I'm going to leave this as a. And I'll put 1 right here for us. And then this is plus 6. I'm going to subtract 6 from both sides. So I'm going to say 2 minus 6 on the left. Okay? And this is going to give me negative 4 is 2 minus 6 is equal to a. And that is it, because 1 is just there, but that's okay. And we can divide by 1, but that would give us the same thing. So our a is equal to -4, and we wanted a negative number, so that's good. All we have to do now is our last step, and that's write the equation. Well, if we know a is -4, and we know h and k, then we know our equation. So it's f of x is equal to -4 is a, times x minus 3, that's h from our vertex, squared, plus 6. And this is really what the question is asking for, and we could not have done it if we didn't solve for a, because we needed a. So that's how to do it. I would say the steps in order. Number 1, plug in your x and y over here, and then plug in your vertex h and k, and then solve for a, and then rewrite the equation. Okay, so one more quick example. This time you're going to be given the point -3, 9, and the vertex -2, -1. And again, the first thing I always do is just make sure I realize, where I'm plugging everything in. So if I write this out, it helps me keep it straight. F of x is equal to a times quantity x minus h squared plus k. And also, the more I write it out, the deeper I know it. So, all the better. Okay, we're going to plug in x and y, and then h and k. And so y is, again, f of x. So we're going to start off here. Let's start off with 9 is y is equal to a. X is -3. And then I'm moving on to h, which is -2. So this becomes +2. And that's squared. And then plus -1, so -1. Okay, I've got x and y in there, and I've got h and k in there, and now all I have to do is solve. And so I'm going to say 9 is equal to a times -3 plus 2 gives me -1 squared minus 1. -1 squared is, again, wow, this is going to work out really nice. That's equal to 1, so I'll just leave it as a. I'll put it in parentheses for you. And then -1, so plus 1, and then 9 plus 1 is 10. This gets rid of that, and then this is equal to a, and so a is 10. And the last thing to do is just to plug in. So we have f of x is equal to a, which is 10, and then let's see, times x minus h. H is up here, -2, so that's +2 because it's flipped. And then k is -1, so that's it. That is the equation right there that fits it. And if you hang around, I'm going to transform this equation here into standard form. So if you want to remember how to do that, then keep watching. Okay, the last thing I'm going to do is transform vertex form into standard form. And if it asks you on the test, please give us an equation that, crosses over a point and then has the vertex as such. You don't have to do this, but you will have to know how to convert a vertex to standard and then eventually standard to vertex. And this isn't bad. Again, just a reminder, the key is to follow order of operations. And if you're in first period, then this is Killian's jellyfish can do it, or something like that, which is really cool. So if you're not in first period, then you're just following parentheses, exponent, multiplication, division, addition, subtraction. But alright, let's do it. Well, the first thing is the parentheses, and x plus 2, well, that's just x plus 2, can't do anything there. But I can square it when I handle the exponent, so let's do x plus 2 squared, which is x plus 2, then times x plus 2, and that gives me x squared plus 2x plus 2x plus 4, which gives me x squared plus 4x plus 4. And if you remember, we still have all this other stuff. This is multiplied by 10, and then we're going to subtract 1. And the next step is multiplication and division. So we're going to multiply the 10 across. So when we distribute this 10 to all the terms, we're going to get 10x squared plus 4x times 10 is 40x. And then 10 times 4 is 40. And then last thing we're going to do is this minus 1 right here. And that should give us 10x squared plus 40x. And then 40 minus 1 is positive 39. And this is standard form. This is not good at telling me the vertex. I really can't see where the vertex is from here. I know that the y-intercept is 39. That's helpful in some cases. Yeah, I'm not sure. I think I like the vertex form better, but that's how I convert it, and at least I know how to go back and forth. So, great. Have a great night. Thank you.